Okay, my name is Aidas. I'm working Danske Bank. I like to present me as a software developer, but I am an architect here. My usual work is development and a lot of issues solving. So let's talk today about moonshots and technologies. Our agenda, what I said, is moonshot, technologies, and later I will show a quick live demo how to use cutting-edge technologies and to achieve some working concept. So, what is a moonshot? Anyone knows? What's that? Someone?
When you shoot and hit the moon.
Maybe. Any more ideas? Maybe something? Yeah. No, today I won't talk about NASA's moonshots. I will talk what we in Danske Bank do. For beginning, I will show this number. This is quite a huge number, 27 million. Maybe any guess what's that? Anyone? What?
Users?
Maybe. Very, very close. It's a population. It's population in Nordic countries. And why I'm saying to that? Because Danske Bank, we have a new moonshot. And it's not only Danske Bank. It is in Nordics. I mean, we have 5 countries, 7 banks, and we have a new moonshot. And what's it about? It's about payments. Nothing fancy, but it's cross-border payments. And to be more accurate, it's cross-border real-time payments. So just imagine how you are doing payments today. If you want to do payment from one bank account to another bank account, you need to wait about 4-8 hours. It depends where you hit. And if you are unlucky and it's a weekend, you will wait until Monday. So, for example, this number needs to wait Monday, yeah? It's not very nice. So, Nordic countries and these 7 banks agreed to change their infrastructure, fundamentals of their infrastructure. So, this is quite huge moonshot. To be more imaginary here, just imagine if you have a huge skyscraper, yeah? New York, Dubai, or something like that. And your task is to change fundamentals of that. Sounds like an impossible mission, yeah? But to be more fun, add that all people must be inside and keep working. No casualties allowed. Yeah? So, moonshot about this. Next, what qualifies to be moonshot in Danske Bank? I talked about currently one moonshot. So the idea is huge problem. So we have a huge problem. We need to take a radical solution and use new technologies for that. So now we are a little bit familiar with moonshot. Let's dig in technologies part. And technologies part, I split it in 3 groups. One for development, data storage, and of course operations. Let's start from development. .NET. In Danske Bank we can choose. We can use .NET Framework or .NET Core. Second thing what we can choose is Visual Studio or Visual Studio Code. When we have source code, then we need to put somewhere. One of the tools is Bitbucket. Bitbucket is source repository with a JIT. Do you know what that? Yeah, here is Swagger. We use a Swagger for OpenAPI. We have a lot of services. These services use REST APIs and need to communicate together. And of course, we have a lot of teammates, other development groups, and we need to give idea what we done and what we are using. So Swagger helps a lot. Next thing, ReSharper. I suppose you know that all. If we chose to use Visual Studio, then we can use ReSharper here. ReSharper helps us in a lot of ways. It can help in better code quality or learn something new. For example, if you missed something new from C# language, yeah, it helps a lot. Uncrunch. Uncrunch is utility to run unit tests constantly. You are developing something, and Uncrunch runs your all unit tests. If something you changed in your code, it knows, and it runs unit tests again. And if you broke something, it will allow you to know immediately. And another good thing about Uncrunch, it is Visual Studio plugin, so it displays which code lines are covered by unit tests. So how it's awesome. And of course, you are getting code coverage. Last but not least, Docker containers. I put it in development because we start using Docker in the beginning. When we start the first code line, and somehow we need a Docker. Then, data storage. We use Cassandra. Cassandra we use for big loads and scalability. But of course, we have an SQL server. We need a SQL server when we need very simple queries or make customized reports. And of course, the SQL language itself allows a very good collaboration between tools. Operations. I put here RabbitMQ, messaging broker. Messaging broker could go in the first stage, of course, too. But in operations, all magic happens in operations. Red Hat OpenShift, it's quite an interesting thing. I will say a little bit more about this. If you are using Azure or Amazon Cloud, it's a very familiar tool. It's a platform as a service. And this tool could be used locally in the company in premises. So we're using that to run all our applications in the cloud. It uses Docker containers and Kubernetes. So it's based on existing well-known infrastructure. And last but not least is GoCD. GoCD is a tool which allows you to create a lot of pipelines. These pipelines allow you to automate your builds, automate your tests, and automate your deployment, and do everything in one go. So you have a continuous integration, continuous development tool. We talked about technologies. Now, when we have a bunch of technologies, we need to mix and match everything. It's sometimes hard, sometimes easy. But let's answer to one question. What do you get when you cross a cow with a trampoline? Anyone knows?
Broken trampoline.
Maybe. Close. A milkshake. So if your goal is milkshake, it's good, yeah? You know that you need a milkshake, so you could mix and match technologies to get milkshake. It is good if you know what you want. It's bad if you don't, then you can get an unexpected outcome. So the danger is to get an unexpected outcome. So please be very careful when you're choosing technologies. Even you are sure that it's good. Sometimes happens that you start asking what to choose and what to use. There's a lot of articles. You can read about it, what technologies goes together well, what's not, what you can get when you want high performance, scalability. But one advice from me, look at your teammates, what they know, what they do after the work, what he did in previous project, the previous company. Because at the end, this matters. Because if you take new technology and your team doesn't know anything about it, it will not go good. So trust your teammates and don't use new cutting-edge technologies just because it's cool. You read about yesterday. It's not going to work. I talked that I will show a demo. So I have a bunch of technologies. I need to mix and match something for a demo part. So let's do that. you saw I moved Docker to operations. I will use Docker to bring up new Cassandra node. So for that one. So what will be the demo? The demo will be a very simple application, .NET application. It will allow us to add message and receive message. Simple as that. But to do it, we will use one microservice, one Cassandra node, and everything in the private cloud. So it will be 3 steps. I will explain these steps to you now, and it will be easy to talk about it later. So first step, I will take a source code, Visual Studio Code. I will explain a little bit. Then with the code, we will get a ASP.NET application. You can call it microservice because it will have a REST endpoint to add or receive messages. Second phase, I'll take a Docker host, Cassandra image, and from that we will receive new instance of database. And of course, we have source code in the Bitbucket from first stage, then OpenShift. I talked about OpenShift. I will show how it works. And from that, we will have everything in the cloud. So let's go to the demo. So first of all, let's check the code. As I said, I will use .NET Core application 2.0. It's quite simple, but I think most important thing is a controller here. So let's dig in. We have message repository controller, and it self-describes what it does. And we have 2 actions, post and get, very simple ones. So as I said, we need to post message, so to add to the database, and get to receive it. Let's check about get. In the get method, we have repository, and this will stand for our database. So looking from where it comes from constructor, and construction is interface. So I'm getting feeling that we are talking about dependency injection here. Yeah. So, and that's it is. .NET Core applications comes with dependency injection out of the box. So it's very easy to use it. Just look at this line. I have repository interface and Cassandra repository implementation, and I'm binding this here. That's it. No more magic. Just that. To check more on repository, on Cassandra, it's quite simple. We have configuration reading and initializing of database. So we have source code, and this is a Bitbucket. It's user interface for Bitbucket. If you are used to GitHub or similar tools, it's very similar and nothing fancy here. So this is first stage. Now I need to create a Cassandra base. It will be a little more interesting. I'm quite lazy. I always forget Docker commands, so I have cheat sheet here. I'll take this one and here. But before creating new container, I will check if maybe it's running. No, so we can take new. With this line, what I'm saying, I'm using Docker command line, using remote machine in cloud, and I'm saying that I want to create new Cassandra container from existing Cassandra image, and I'm asking to make port forwarding to be able to access the Cassandra database from outside. So let's hit, and container should be running. Let's check if our Cassandra is up and ready. This is DataStack's Dev Center. It's a management panel for Cassandra bases. I have prepared the connection string before. Yes, and we have. It's totally empty new database, fresh one. So second phase is done. It's quite easily with these tools. So now we need to run our application. And OpenShift is here. So this is OpenShift user interface. It's quite simple, but in the same time it's very powerful. We have overview of all applications running in it, application configuration, builds, resources, storage, and of course monitoring. But today I will just add new project, and it's loading. Couple seconds. Yes, we're dealing with .NET, so I will choose it. And .NET Core, of course. Yes, we need to name it, so like demo1. And now I need a source repository address. I will take from here. Let's add here. And now we need to be a little bit more advanced because you cannot access Bitbucket directly. You need some authorization on it. And we have source secret here. And we can check what's more. It's a routing. You can modify routings. You can add SSL on top of that if you need more security. Then there's environment variables for configuration, for deployment, and most interesting thing here, I could say, is scaling. Now it's manual, but you can choose automatic. So OpenShift will ensure that by your configuration, it will scale your service if you want that. There's a couple sections more. There's resource limiting. For example, you want to limit your CPU or memory. There's a lot of these ones, but I will be simple. I just create application. Let's check how it goes. And yes, our application is running. Not running, just deploying. It will take a couple minutes. It's a fresh instance, totally new. So I won't waste time. I will show the application work from my machine, and later I will be back. Let's start our service here. I'm using Visual Studio Code. I very like that. I feel like a hacker. Good tool. But okay, we are running. And we get a browser. And I hope so we will see, yeah, it's a Swagger interface. I talked about it, and you, I suppose, know it. What I showed in controller, there's the same thing, message repository, and both calls, get and post. So be simple, I'm going to post. Let's try add something. Let's add ID, my first message, and execute it. And what we have 201. It's success. And additionally, we have a response body with my IDs, with our first message, and creation time. It's quite easy. But I remember I said that base was totally empty. So let's check what it is now. I see this Tech Night key space and one table. So the application created all tables, key spaces on the first hit because it didn't find anything. Just check what we have here. Run the query, and yep, we have our one message. So database works. Let's go back to the Swagger interface, and we added new one. So let's try to get it. And give ID, execute it, and that's it. 200. response is here. So it's, you see, it's quite easy to test your endpoints. It's nothing. Now let's check how OpenShift is doing. It's still building. So let's talk about Swagger more. For fun, I will try to get something what's not database. And yep, not found, 404. So as you see, it's a very powerful tool. Just imagine if you now have REST APIs, a lot of services, and you want to talk with your colleagues to explain how it works, you need to make a meeting, to talk, to write papers, or to have a space somewhere where you exchange technical documentation. But instead you can just give a link to your working service, just with the ending Swagger, for example, yeah, and you will get this UI. Here you can just see your models, your calls, what to expect, what you need to pass, and what outcome you could get. Is it to one is positive or not? So it's a very good communicative tool too. Yep, and OpenShift has done its job. We see here's one pod. Pod, it means that entirely new container is up and ready, and it's working. So here I have an address of newly created application. Let's check it. Just I need to add more routing here to be able to access Swagger. And now you see the URL is from private cloud already, not on my machine. While it's loading, just a couple things here. In this management panel, you can see how much resources your application is using. And one important thing, what I want to mention here, you can ask why to use OpenShift, why not just simple Docker containers. For example, if I want to scale this application, when I have two instances, I can create one Docker, then clone another one. So I have two containers. And for example, client is here, how he knows where to go. Yeah? So the simple thing is to place load balancer. It's quite easy, but I need to have load balancer, I need to make configurations, and if, for example, I take out one container, what then? Or, for example, I add 3 containers, what's then? So instead of doing that, I can come here and just press this button. And scaling is automatically. And what I told you, I don't need to do it at all. And in a couple seconds, I will have 2 running pods. If you trust me, I would say if it will scale, and if I press this button down, it will scale down as easy as it goes up. So, but you need to trust me on that one. And with that, I need to end this. Yep. And with this all, I want to sum up with 2 things. One thing is project is called Moonshot because it's not easy, because it's extraordinary. And what I mean by extraordinary, it is hard, and hard in every aspect. And second thing, we use cutting-edge technologies, not because it's cool or we can, but because we need to survive. So thank you for your time.